Good evening and welcome back to How to Organic Chemistry. I'm Head Chemist Kaylee and this is Head Chemist Madison. Tonight we're going to be discussing an elimination reaction. We've been getting several phone-in requests on how to do an E2 elementary step bimolecular elimination reaction. So tonight we're just going to give you an example and kind of show you the step-by-step. Madison, do you want to give us some background?
Sure. Okay, so an elimination is going to be when the H atom and a leaving group leave at the exact same time from the substrate. That's why it's called an elimination. And a bimolecular, it's called bimolecular because there are two reactants in this step. So we're going to go ahead and give you an example of a bimolecular elimination step. So we have the substrate here, and then we have a base over here. So two lone pairs from the base are going to attack the hydrogen, taking the hydrogen and forming water, and the electrons from that bond are going to form a double bond between the carbon and the chlorine, which is going to be the leaving group. And it's going to leave at the same time, and then it forms the product over here, which you can see has a double bond with no leaving group and the formation of water. And that is what an elimination is, an E2. It is going to be one step, and it is going to form a double bond in the product. So we are going to be discussing how to chair E2 addition, and I have the starting product and the chair 2 conformer, and it is going, this is the unfavorable position. So this is the chlorine, and then these are the two hydrogens that could potentially be pulled off, and you can see that the chlorine and then these two hydrogens are going to be 60 degrees away from each other, and that is why it is unfavorable. And so Kaylee is going to discuss the Fisher projection of the starting product.
So it's a little bit easier to see on the board. This is a Fisher projection of the unfavorable. This is our chlorine leaving group. As you can see, the hydrogens are only 60 degrees away, which is not favorable. It wants to be antiperiplanar. So over here, we have our chlorine leaving group and our hydrogen, which is 180 degrees away, which is antiperiplanar.
Okay, we're going to be discussing the chair conformer and the unfavorable position and how it gets to the favorable. So this is a chlorine, and then these are the two hydrogens that are 60 degrees away from each other, and it wants to be 180 degrees away to be antiperiplanar. So we're going to flip this down, flip the opposite up, which pushes this down, which makes this chlorine and this hydrogen 180 degrees away from each other, which is antiperiplanar, and it's also favorable.
Okay.
Kaylee's going to discuss the product.
Yeah, so this is the product. It is not in a chair conformation, but we just wanted to show you that it still has the methyl intact. Our chlorine leaving group fell off. Our hydrogen came over and formed a double bond, so we have one hydrogen on here and one hydrogen on here, and this is our product. Thank you for joining us this evening as we How to Organic Chemistry E2 edition.
If you have any questions, feel free to contact our website, howtoorganicchemistry.com.
Have a great evening.